Could there be an edge of the universe? Hello, cosmic explorers, and welcome back to Cosmic Enigma. Today, we're diving into one of the most mind-bending questions humanity has ever pondered. Does the universe have an edge? When we think of an edge, our minds often conjure images of a giant wall, a sudden drop-off into nothingness, or a boundary we could somehow reach. But the reality of the cosmos is far more intricate, and frankly, much stranger than we can easily imagine. Our brains, after all, aren't exactly wired to comprehend the infinite. To truly unravel this mystery, we first need to understand a crucial distinction: the difference between the observable universe and the entire universe. These two concepts are often confused, but they hold the key to understanding whether our cosmic home truly has a limit. Imagine our Earth at the very center of a giant cosmic bubble. This bubble is our observable universe, the region of space from which light has had enough time to reach us since the Big Bang. Think of it like this: light travels at an incredible but finite speed, and the universe itself has a finite age, about 13.8 billion years. So any light from beyond a certain distance simply hasn't had enough time to make its journey to our telescopes. Due to the continuous expansion of space since the Big Bang, objects whose light started traveling 13.8 billion years ago are now much, much farther away. In fact, current estimates suggest our observable universe stretches about 46 billion light-years in every direction from Earth, making it a staggering 93 billion light-years across. The farthest we can see is the cosmic microwave background, the faint afterglow of the Big Bang itself, a snapshot of the universe when it was just a baby. But here's the crucial part. This edge of our observable universe isn't a physical barrier. It's merely a horizon, like the one you see on the ocean. Just as a sailor can't see beyond the curve of the Earth, we can't see beyond this cosmic horizon. It's a limit to our perception, not a physical boundary of the universe itself. And this horizon is always expanding as more light reaches us, though some distant regions might eventually move beyond our reach due to the universe's accelerating expansion. So, if the observable universe has a limit, what about the entire universe? Does it have a true physical edge? The overwhelming scientific consensus is a resounding no. The universe as a whole doesn't have a wall you could bump into or fall off. Space itself stretches out infinitely in all directions, filled with galaxies as far as the eye, or rather the telescope, can see. This idea is profound. The universe isn't expanding into anything, because the universe is everything. There's no outside for it to expand into. It's like the dough of a giant, infinite raisin bread. As the dough bakes and expands, the raisins, galaxies move farther apart from each other. But the bread isn't expanding into some larger kitchen. The space between the raisins is simply stretching. It's a concept that challenges our everyday intuition, but it's fundamental to understanding our cosmos. Now, let's talk about the universe's shape. Einstein's theory of general relativity tells us that mass and energy bend space-time, and this bending determines the universe's overall geometry. Cosmologists use a parameter called omega to describe this. If omega is greater than 1, the universe is positively curved like the surface of a sphere. If it's less than 1, it's negatively curved like a saddle. But if omega equals 1, the universe is flat, like a vast, flat sheet of paper. And here's the exciting part. Current observations from missions like WMAP and Planck strongly suggest that our universe is incredibly flat, with a margin of error of less than 0.5%. In its simplest interpretation, this flatness implies that the universe is infinite, while it's theoretically possible for a flat universe to be finite if it has a complex, multiply connected topology. Imagine a cosmic Pac-Man game where you reappear on the other side if you travel far enough. The evidence strongly favors a simpler, infinite structure. The Big Bang wasn't an explosion in space, but the rapid expansion of space itself. Every point in the universe is moving away from every other point, without a central origin. This expansion is not only ongoing, but accelerating, driven by a mysterious force we call dark energy. This means the distances between galaxies are growing faster and faster. In fact, recent measurements of this expansion rate have created a puzzle known as the Hubble tension, suggesting our current models might need a major rethink. This brings us to the cosmological principle, a cornerstone of modern cosmology. It states that on the largest scales, the universe is both homogeneous and isotropic. Homogeneous means it looks the same everywhere. There's no special location. Isotropic means it looks the same in every direction. There's no preferred direction. If the universe truly is homogeneous and isotropic on large scales, then it simply cannot have a center or an edge. A center would imply a special place, and an edge would mean it's not the same everywhere. Observational evidence, particularly from the cosmic microwave background, strongly supports this principle. So, what's the final verdict? Based on all the evidence we have, while our observable universe has a horizon, the universe as a whole appears to have no physical edge. It is vast, flat, and most likely infinite. This understanding, though challenging for our human minds to fully grasp, is the most logical conclusion derived from decades of scientific observation and theoretical work. But the journey of cosmic discovery is far from over. The precise topology of the universe, the true nature of dark energy, and even the mind-boggling possibility of a multiverse, where our universe is just one of countless others, remain profound mysteries. These aren't isolated questions. They're interconnected pieces of an even grander cosmic puzzle. The universe is a boundless wonder, an ever-unfolding enigma that continues to challenge our perceptions and expand our understanding. It invites us to keep asking questions, to keep exploring, and to marvel at the profound complexity and interconnectedness of everything that exists.